Hello everyone, and welcome back to our section on NumPy. In this lecture, we're going to have a look at how to index and slice NumPy arrays. Let's move on over into our Jupyter notebook and get started. Like before, the first thing we'll need to do is import NumPy. So we can go ahead and say import NumPy as np. Next, I'll create an array of 10 numbers, starting from 0 and then finishing at 9. So I'll just use the arrange function to do this. And let's now use indexing to extract individual elements from this array. Indexing NumPy arrays works in pretty much the same way as our regular Python lists, using just the same square bracket notation that we used before. To index this array, at index position 5, we would call the name of our variable, and then inside of our square brackets, we just pass in the number 5. And then if we run this, it'll return 5. Like with regular Python lists, NumPy arrays are also 0 based. So our first number here of 0 is at index position 0, 1 is at index position 1, and so on for the rest of our array. This time, the index and actual number itself match up because our array starts from 0 instead of from 1, as we used the arrange function to create the array. If we wanted to extract multiple values from this array, we can use slicing, just like we did with our list previously. Let's say that we wanted to extract 3, 4, and 5 from our array. We'll begin by entering our starting index, which will be position 3, a colon to indicate that we want to slice, and then for our stop value, we'll have to enter 6, because like before, the stop value is not inclusive, and will therefore only return up to, but not including the stop value. If we run this, it'll then return our numbers of 3, 4, and 5. So as we've just looked at, indexing and slicing work pretty much the same way for our arrays as they did for regular Python lists. But one way that they do differ is the fact that with NumPy arrays, we can perform something called broadcasting. Let's go ahead and look at an example of what I mean by this. Let's select our array variable again, and then we'll slice from index position 3 to 6. And here we can then say that this is equal to 10. What this will do is set or broadcast that value of 10 to those elements inside of our array. And then if we have a look at our array again, we'll see that these elements have been updated to the value of 10. This brings us nicely onto another important topic, which is how different views of our arrays work in NumPy. And let's create a new array to demonstrate this. And I'll just call it array 2, and then it'll contain 10 numbers going from 0 to 9. And with this made, let's create another variable which will be a slice of this array. So let's have from index 2 to index 7. And then if we have a look at our result, as expected, we'll see that it's returned from 2 to 6. So I'll now go ahead and mutate or change this slice by broadcasting the value of 100 to a few elements inside of it. And we've now got 2 elements inside of here that are equal to 100. If we then take a look at our original array, which was array 2, we'll see that the broadcast that we made to the slice is also reflected in the original array. So slices of our arrays are actually just a view of the array and not an explicit copy. And this works in the same way that it did for our lists when we looked at lists in the previous section. And the reason that NumPy does this is to help with memory management. If you'd like to create an explicit copy, you can pass in the copy method. Okay, great. So far, we've covered how to index and slice our one-dimensional arrays, as well as broadcasting and how views of our arrays work. Next up, let's discuss indexing two-dimensional arrays, so our matrix array type. I'll go ahead and create a new matrix, And I'll create it with 3 rows and 3 columns, with numbers starting from 10 and then going up to 90. And we can create this just like we looked at in the last lecture with a list of lists. And let's now say that we want to grab the first row from our matrix here. So 10, 20, and 30. We'll start with our matrix variable name, and then as this is the first row, we can pass in 0 to our square brackets. And if we run this, it'll return the entire first row of our matrix, as we can see here. And then from our first row, if we wanted to select 20, we could then open another set of square brackets. And as this is the second element, we would then just have to pass in 1, and then this will return the single element of 20. Instead of using 2 sets of square brackets, like we've done here, we could also just open 1 set, but then separate our 2 numbers or index positions with a comma, like this, and that'll work just fine too. Have a go now and see if you can select 70 from this matrix here. Okay, so I hope you were able to get that. The solution to this would just have been the index of row 2 and then column 0, like this. Okay, so moving on, we'll now have a look at how to slice a 2-dimensional array type. So we'll have a look at slicing our matrix. For this example, let's extract the values of 20, 30, 50, and 60 from our matrix, so all the numbers in our top right corner. We'll go ahead and call our matrix variable, and then the first thing we'll need to provide is the slice for our rows, and since we need the top 2 rows, the slice will be from index 0 to 2. And remember that we use 2 here because the stop value is exclusive and doesn't include this number. Then we can put in a comma to move on to our columns, and here we needed to select the second and third columns in our array, so we can say 1 to 3. And if we run this, we can see we have our result here. To help explain this, let's have a look at this PowerPoint slide, which shows a few different examples on slicing a 2-dimensional array. And our array here has got 9 numbers going from 0 to 8, with 3 numbers in each row. Along the top, we have our column index numbers, and then going down the side, we have our row index numbers. At the left-hand side here, we have our first example, which is in this dark orangey brown colour. And this is a slice on row 0 and a column index 1 to 3. And if we look over here to the right at our matrix, we'll see the numbers that this selects in the same orangey brown colour. And this slice will select our first row and then the column of 1 to 2. And this returns the actual values of 1 and 2. And we can see this highlighted in the same orange colour. Below this, we've got an example of rows 1 to 3 and then columns of 0 to 2. Accounting for the stop value, this actually selects rows 1 and 2 and then columns 0 to 2, which are the numbers of 3, 4, 6, and 7. And again, you can see these over here in our matrix on the right. Our final example just selects our second and third rows and then the final column at column index 2, which gives us the values of 5 and 8. This type of slicing won't really be that necessary when you're doing data analysis work, so if you don't understand it completely, then don't worry. But it is still a really good example and a way of learning about how NumPy arrays and indexes work. And let's now move on to discussing the final 2 topics of this lecture, which are Boolean indexing and Boolean masks. Boolean indexing allows us to create a Boolean array based on a Boolean condition. And for example, let's go ahead and create a 1-dimensional array containing a few different names. If you'd like to copy and paste these names, you'll be able to find this code in the associated notebook for this lecture. So I'll put in Jack, Joe, Jane, Lucy, Alex, and then just a few more names in here at the end. And it's possible for us to take our names array here and then use comparison operators on the array to return a Boolean array. Let's go ahead and then say names, but where our name is equal to Joe. And if we run this, it'll return an array of Boolean values, so true and false. The true element here is at index 1, which is also where our name is equal to Joe in our original array. If we do the opposite of this and say where names is not equal to Joe, we of course get the opposite output, and this also works on numeric arrays too. So if we have an array of values ranging from 0 to 10, we could look at values that are less than 6. We can then take our Boolean array that we've just created and use it as what's called a Boolean mask to filter another array. A Boolean mask is a concept in programming, particularly used in array-based operations to filter or select elements based on Boolean conditions. Let's create a new variable, which I'll just call Boolean numbers. And then this will be a Boolean array for our numbers array, where our value is greater than 5. And then this is our output here. We'll then put our Boolean numbers variable inside of these square brackets for our numbers variable. And then this will only return numbers where the Boolean numbers variable was true. So in other words, where the number was greater than 5, as we can see here. Alternatively, we could also pass this Boolean condition straight into our square brackets as well. So numbers, where numbers is greater than 5, and this will return the same output as above. Okay, so that there is our lecture on how to index and slice arrays inside of NumPy. So as mentioned, slicing is not performed too commonly throughout data analysis tasks, but it's still a good way of learning how indexing works. Indexing will be a far more common task that you'll have to perform, so as long as you're comfortable and confident with indexing, then you'll be completely fine. In the next lecture, we'll have a quick look at some universal functions as well as some other array manipulations.